Hi, this is part of the video that I'm preparing for the final to run the linear regression based on the Boston housing data for the sake of Skyfi program as an assignment that was assigned to the participants. Initially this particular, so let's go through one by one. So in this particular box 78, I'm running this in the Jupyter book, so I run enough number of times so the number is staying there. So anyway, this is the thing. So basically I'm uploading all the NumPy and Scikit and MATLAB libraries as part of the Python program. So I run this and I'm loading this. Actually basically I'm loading this particular libraries into the system. So once it is done, uh, so this I'm running it. So now after it has processed the the import libraries, and now I'm in the next step here. And once I load this, it goes to the next one. So it loads the Boston data from the Scikit dataset, scikit-learn datasets. I'm just printing the list of description of the Boston dataset. What are the how many attributes and how many rows are there, and 13 categorical features, and the 14th one is the target. So this so next I'm at this particular, it's load the Boston data, and again running it, running and rerunning it. So this particular features it runs, and it loads the data frame PD as part of pandas data. It creates a data frame set of the Boston data based on the feature names, and once it loads, uh, it it shows all the features that are there in the data frame. Then I'm just running a few test cases as to whether it really loaded, and 506 rows, whether it has loaded into 13 columns. So I'm just checking one of the feature column, which is the age. Then target, looking at all the targets. So the max of the target is 50, the min is 5. So just running through. Then I'm concatenating the features in the target based on each axis, each row, and it concatenates. Then rounding it to decimal of 2. Then I'm running a correlation of every column of the data. So using that particular algorithm, data frame dot correlation of the Pearson, it does that. Then I'm actually looking at the absolute values of all the attribute at target for in the list features. Then I'm combining the correlation of the features, and I'm creating a lambda function where x has a reverse true, so reversing the values. And then I'm running it through the as a label of all the features with the correlation, which one has the largest correlation to the target. So once I run it, it creates a graph of it. And LSAT gives the LSAT is the feature which has a largest correlation with the target. The next one is the RM. Okay, RM is average number of rooms per dwelling, and LSAT is the percentage lower status of the population. So basically the lower the lesser the number of people and more number of rooms, they are the ones which actually determines the cost of the rooms over there in that particular area, Boston area. So then I get the X and data frame of LSAT values and target values, and looking at the correlation. Just I'm printing the uh, y values, then I'm getting min max scalar. So let's run one by one, and running through the y max. Here I'm splitting the data set, the Boston data set, into 4 pieces: X train, X test, Y train, Y test, in percentage of 20% based on X and Y, split of X and Y. Test size is 0.2, that means 20% of it will be trained and the rest would be to test it. Okay, Y, X and train of X train of 80% will be there, Y train will be 80%, X test and Y test will be of 20%. So I'm actually running through this again. So I have the values of all these 4 values. It extracts, and I have so I'm going through. I have created few methods. This method update and error, as shown in the lectures. So I have these error values which are supposed to be calculated against the slope of each of the values of X and the predicted values, right? And then the gradient descent, and here I'm running it based on the initialized 0.9, init sees 0 and running rate at less than 0.025%, so it is 0.01, iterations 250. So I send all this information to the gradient descent, which was defined over here as a function. So it does the job of running it, but there are some value, the anim and HTML are failing, and I'm not looking at how to resolve this. So this is it. So it is running up. So this is the state of the darts, the information that it has correlated based on the LSAT and the training set. So I run the plot scatter train Y train color beam, and for some reason I have no idea why instead of it's drawing from the left top to the right, it is actually drawing from here to there, and I need to resolve this part, but since today is last day I could not. So again I run this plot, and iterations are also number of iterations to that is also failing. So anyway, the predicted value, the mean scared error is around 14%, and I run this through. Again, the X and Y and targeted value is very high. It should be in less than 10%, but since the line itself is wrongly calculated, I have no idea why it's doing it. So here is the predicted and values that are giving a line, and the linear regression values is not in the way that it's supposed to do, but for some reason it's getting wrong information. So, or I must have programmed wrongly. So here it is. So finally the targeted values are X, Y, and predicted values are this. So it actually has given certain values, scaled values, and the outputs are coming up. So the top of it, so it has scaled nicely, I think, but somewhere I'm not able to be sure why this linear regression value it's supposed to be doing, instead of from 1 to 1 on the left side on top to this side, it's supposed to run, it's giving wrong values. So this is the final run that I could do. I don't know where I have done wrong. but somewhere it is in this corner. I know that somewhere I must have sent a wrong information here. X1 y1 x2 y2. So this is it, and I think this is the run of it. Hopefully this will I will come to know what wrong I have done once I upload this. So